Hello students, this is the second problem of Kaplan turbine. Okay, so determine the efficiency of the Kaplan turbine developing a 2940 kilowatt under a head of 5 meter. It is provided with a draft tube with its inlet diameter of 3 meter set at 1.6 meter above the tail race level. Okay, so the vacuum pressure gauge is connected to the draft tube inlet, indicates the reading of a 5 meter of the water. Okay, so assume that draft tube efficiency is 78%. Okay, so this is a draft tube. Okay, so D2 is given, that is a 38 outlet. Okay, 38 meter square. Okay, so head HS is given, that is 1.6 meter, and P2 by rho g is given, that is 5. Okay, so here for this case we have to apply Bernoulli's equation, that is P1 by rho g plus V1 square V1 square by 2g plus h, right? So which is equals to P2 by rho g plus V2 square by 2g plus hs, right? So here we have to use P2 P2 by rho g plus V2 square by 2g plus hs. Okay, so here we have to take uh, P2 by rho g to the left. Okay, so the entire equation becomes P2 by rho g, which is equals to minus of hs plus V2 square minus, here two diameters are there, right? So V2 square minus V3 the square divided by 2g. Okay, so substitute all the values. P2 by rho g is given, right? So that is 5, right? So which is equals to minus of 1.6, that is hs, into V2 square minus V3 square divided by 2g. Write it as it is. Okay, so here uh, uh, you will get V2 square minus V3 square divided by 2g value as plus 3.4 meter. Okay, so uh, next step is V2 square minus V3 square, which is equals to 66.708. Okay, so put it as equation 1. Okay, so for a tube efficiency, that is ND is equals to it is a ratio of actual pressure gain in a draft tube to the velocity head at the inlet of the draft tube. Okay, so that is V2 square minus V3 square divided by 2g, that is a actual pressure gain in a draft tube. Okay, so the velocity head at the inlet, it is given by V2 square divided by 2g, right? So V2 square by you can write it as V2 square minus V3 square divided by V2 square. Okay, so which is equals to 0.78. Okay, that is 1 second. Yeah, the 0.78 is given, right? So which is equals to 0.78. So substitute all the values, that is this is the V2 square minus V3 square divided by V2 square can also written as 1 minus V3 minus V2 the V3 divided by V2 the whole square, which is equals to 0.78. So V3 the square is equals to 0.22 times of V2 the square. Okay, so uh, put this value in equation 1. So that is V2 square divided by 1 minus 0.22, which is equals to 66.708, right? So V2 you will get 9.25 meter per second, that is VF. Okay, because axial discharge in Kaplan turbine. Okay, so the discharge, okay, Q is equals to AF into A, and Q is equals to A into V, right? So that is AF into VF. Okay, so which is equals to pi by 4 into 3 the square into VF is 9.25. So Q you will get 65.38 meter cube per second. Okay, so the next part is we have to find the overall efficiency of Kaplan turbine, right? So the overall efficiency, which is given by power output divided by hydro power at the inlet, right? So power output P divided by rho Q into GH, right? So all the values are known, so substitute all the values. That is P is 2940 into 1000 divided by rho is 1000 into G is 9.81, Q is 65.38, and H is 5. Okay, so overall efficiency you will get 91.68%. Okay, so this is about the second problem. Okay, thank you.